Hello, this is a little calculus 1 for you. Again, I think I'm in section 5.3 where we're talking about area and integrals. And so I made up this question. I like the way they word these questions. Find the area of the region bounded by the curves x equals 0, y equals 0, and 3x plus 5y equals 15. You know, I called them curves, but these are all straight lines. But this is the proper way to word this question. I want to find the area, and when you find the area, you're finding the area of a region in the xy plane, and these are the boundaries of the region. So one of the boundaries is x equals 0, that's the y-axis. Another boundary is y equals 0, that's the x-axis. And the other boundary is this line, 3x plus 5y equals 15. So I plotted it and drew a picture for you. The book has, anyway, you might have to draw your own picture. That might be part of the task. But at first the book gives you a lot of pictures, and then they want the area. Now the truth is, this is a triangle, and the area is 1/2 the base. I think the base is 5. I think the height is 3, 1/2 the base times the height, so the area of a triangle. 15 over 2 is 7.5 units, square units of area. You know, we're finding area, but we're kind of unitless here. It's just square units of area. Anyway, 7.5, that's the answer. All right, well, let's do it with an integral. So maybe I should say, set up an integral to find the area. And there actually is two kinds. I haven't shown you this yet, but anyway, let's set up an integral with respect to x. So I'm going to set up an integral to try to get this area. And you know, the concept is there's a bunch of millions of little rectangles sitting here. That's what we've talked about in some of the previous videos. There's one example of a rectangle. And I'm going to add up all these millions of rectangles as they move throughout here from 0 to 5. From 0 to 5. You know, what is the width of each rectangle? I think the width is dx. That little width is dx. And then what I need is the height of the rectangle, which is the y value. So this function solved for y in terms of x. So that means I have to do that little bit of work. Solving for y in terms of x. Let's see here. Y would equal 15 minus 3x, and then divide by 5. So if I divide him by 5 and divide him by 5, I could call that y equals 3 minus 3/5 x. I think I'll just erase that and do that. 3 minus 3/5 x. So that's the name of this function. That's the y value. And that's what you integrate, 3 minus 3/5 x. So if I actually do this integral, it should come out to 7.5. I already know that. It would be fun to do. But I wanted to bring up something I hadn't brought up yet. You can also do this with respect to y. And here's the concept. Instead of your rectangles running vertically, we could do all this with respect to y. I could have some rectangles running horizontally like this. Now let me ask you something. What is the thickness of that rectangle? And you would point to that little change in y, and you would say the thickness is dy. And you're going to do this for all these little rectangles as they move throughout here from 0 to 3. So you could set up an integral from 0 to 3 and do this with respect to y. And then instead of talking about the height of that rectangle, it is still the height of the rectangle, but it's sort of the length of the rectangle, and that distance is x. So now, from here over, we call that distance x. But when we hit the function, what I want is x written as a function of y. So now I have to solve for x in terms of y. If I solve for x, another name for this, so there's 3 names for there's a lot of names. X is negative 5/3 y plus 5. I just solved, what did I do? Move the 5y over, divided by 3. Yeah, there it is. That's the name of that, x. So that the name of this function when you solve for y in terms of x is one thing. The name of this function when you solve for x in terms of y is this. And this is what I need when I'm doing it with respect to y. So I haven't shown you that yet, but you can do that. You can do area a couple different ways. Again, both of these, when you work them out, should equal 7.5. In section 5.3, they're not asking you to work these out most of the time. They haven't taught you how to do this. That's up in 5.4. The fundamental theorem of calculus tells you to do the antiderivative and evaluate it. Let's just do one. I'll do this one with respect to y. Here I go. I'm going to integrate -5/3 y. Let's see. I'm going to add 1 to the power. That'll be y squared. I'm going to divide by 2, so I think that'll be -5/6 y squared. Now I'm going to integrate the 5. That's a 5y. I'm going to evaluate from 0 to 3. I found the antiderivative, and now I evaluate from 0 to 3. I plug in the 3. That's -5/6 times 3 squared, which is 9, plus plug a 3 in there, that's 15. Minus, when you plug zeros in, you get a couple of zeros. So there's gone. Yeah, what is this? That 3 cancels there twice. That's 3. That's -15 halves plus 15. That's -7.5 plus 15. That answer is +7.5. Wow, it worked. This one would be the same thing. All right. Thank you. Please do some homework.